Hello, this is Mr. Wilhelm. We're going to talk about section 1.5 today, talking about midpoint, bisect, and trisect, the definitions of, how to use them in proofs, and how to use them in algebraic problems. First off, when we're talking about bisecting a segment, we could have a point that divides a segment into two congruent segments, and that would be the bisection point. And that bisection point would also be called the midpoint. If we were having two, we could have 2 points that divide it into 3 congruent parts, and they would trisect the segment. And we could also have a segment do the same thing, or rays, or lines that divide the segment into congruent parts. When we're talking about angles, it has to be specifically a ray dividing an angle. So if we have an angle and we have a ray that divides the angle into 2 congruent angles, this green ray is called the bisector, creating the 2 congruent angles. If we have an angle and it is divided into 3 congruent parts, then these 2 rays are the ray trisectors. Now these are the definitions of bisect and trisect. We have to make sure that when we write them in proofs that we are understanding that it has to be written in if-then form. This is an example of using bisect with respect to angles in if-then form, going in both directions depending on if you are given that it divides it into 2 congruent angles or if you are given that it bisects an angle. So go ahead and press pause and copy these 2 if-thens, and this is an example for bisect. In this next problem here, we have naming the congruent segments based on the given information. If we have segment CD and we are given that O is the midpoint, then we can mark that those 2 segments are congruent, creating a statement of CO congruent to segment OD. In part B, we have the segment SW bisecting the segment XV, creating these 2 congruent segments, XW congruent to WV. In number 2, we have that RO is bisecting the angle NRP, so this is the angle that we have, and it's creating these 2 congruent angles. Those 2 angles can be labeled as angle PRO congruent to angle ORN. In letter B, we have 2 rays trisecting an angle, which means we are going to have 3 congruent angles. Those 3 congruent angles being angle SXT, angle TXV, and angle VXW. In number 3, we are given in the diagram the congruent angles already marked, so we need to name what the angle trisector is. And this is the big angle that's being divided into the 2 congruent angles, so the ray JG is our bisector. In letter B, we are given these 2 angles congruent, which means that that must be our trisector ray OK. In number 4, we need to make sure we put our answers in degrees and minutes, and we are given that we're finding XTZ, sorry, and we know that TZ is bisecting, so we know these 2 angles are equal, and in each problem it is giving us the entire angle. So if we know that the entire angle is varying between those answers and it bisects it, then we know that we could cut each one in half. So for the first one, if we know the entire angle is 60 degrees, then we know that each part would have to equal 30 degrees. For letter B, if we know that it is 48 degrees and 50 minutes and we cut it in half, then we get 24 degrees and 25 minutes. For letter C, we have 36 degrees and 30 minutes. Cutting that in half would equal 18 degrees and 15 minutes. When we cut letter D in half, if we were to just divide it by 2, we would get 42.5 degrees and 37 minutes, and we would need to convert to get it to get rid of the fraction, or the decimal, sorry. So by having half of a degree, that is worth 30 minutes. So we can convert that to 42 degrees and 67 minutes, and then we need to simplify by taking 60 minutes away, leaving us with 43 degrees and 7 minutes. If B and C trisect segment AD in number 5, we know that each of these parts are congruent to each other, and we know the whole distance between A and D is 21 units, which means that each segment here must be 7 units long. Therefore, going from -5 plus 7 units would get us to 2. This would get us to 9, giving us the coordinates for and segment AC is 14 units long. Actually, why don't you guys pause and solve numbers 6 and 7. In number 6, when we add the segments together and solve for x, we get x is 14, and when we plug that in, we get that each segment is 22, therefore m is the midpoint. In number 7, when we plug in the information that we're given, and we don't know what VM and S are, but we know they are congruent, so we can plug in x, giving us an equation to solve for x given the perimeter of 62. We can find that VM is 16. Now when we're writing proofs, we have to make sure that we take a look at the given information. And in this first one, we're given that E and F trisect segment DG. And going back to what we talked about at the beginning, we have 2 points trisecting a segment. Therefore, it creates the 3 congruent segments, so we can go ahead and write the proof statement. We have to make sure that we write our if-then based off of what we are given. In this case, we are given that 2 points trisect a segment, so that must be our if statement. And if we're given 2 points trisect the segment, then we know we divide the segment into 3 congruent segments. In number 9, it's a little different based off our given information. This time we're given the congruent parts and we're going to the bisecting parts. So starting with our given information, so by already given the 2 congruent segments, we can prove that the ray bisects the angle, and we have to make sure that we write it in the correct if-then. In this case, we are given the 2 congruent angles, so we're given a ray divides an angle into 2 congruent angles. Then the ray must bisect the angle. The next few examples are talking about using midpoint, bisect, and trisect with respect to a diagram. Make sure that it's very important that you guys label the diagrams as much as possible when you're solving these. In this first one here, we're given that AB is 2x plus 9. We're also given the fact that this is the midpoint of the segment. That means that we know that AB and BC are congruent to each other. So if I had that AC, and the whole thing is 6x plus 3. I could also label BC 2x plus 9 because they are congruent to each other, giving me an equation to solve. And when I solve this, I get x is 7.5. Very important that you always make sure you answer the question at the very end, finding AB. So plug it back into what I have for AB. And I get that AB is equal to 24. In the next problem, I'm given that EBC is a right angle. And EBF is 6x plus 3. And this other part down here, FBC is 4x minus 1. So I know that the two parts, EBF and FBC, that form the right angle. So that means I can add those two up. And that they must be equal to 90, which allows me to solve for x. Make sure to go back and answer the question, finding the measure of angle FBC. So plug in my x value for FBC. I get the measure of angle FBC equal to 34.2 degrees. In the next problem, I'm given that BF bisects angle EBC, which creates two congruent angles. And I'm given that this angle is 3x plus 2, and the entire angle is 9x minus 1. Similar to the first one that we did with the midpoint, if I know that these two angles are congruent to each other, that means I can also mark this angle as 3x plus 2, and then together the two of them form the 9x minus 1, giving me an equation to solve. So now I can solve for x. And then if I'm finding angle EBC, plug it back in for x. I get the measure of angle EBC is equal to 14 degrees. Go ahead and pause the video and solve the last two problems. Number 13, I've marked the different angles given. If we notice here, the red angle of 9x minus 2 and the blue angle of 4x, together they form the straight angle, which gave me the equation down here to add them up and set them equal to 180, giving me my x value, and the dBF being given as 3x plus 1 was only given to help solve at the very end, to plug in the 14 to solve for the angle, which gives us the angle of 43 degrees. In the last problem, notice that the two angles that are given with variables 3x minus 1 and 3x plus 10 together form the angle of 115 degrees. So that gives me my equation. I add them up and set it equal to 115. When I solve for x, I can then plug it back in for angle dBF, which allows me to solve for the measure of the angle of dBF being 52 degrees. And this concludes section 1.5.